All right. Hi, Paul. You got your email, and I was looking at this project. I was kind of stumped on it for a second too, but I think when I give you the quick and dirty your solution on this, you're going to go, oh, that's what I have to do. First thing I got to do, I want to do here though is before we get started on the sheet of paper that I have, and the final velocity will be 14 meters per second. All right, and we're going flat. And so we get 45.5 times 746. Let's get the wattage here. So it's 33,943 watts. All right, so let me show you what I've got here so far. Okay, so here's what I'm working with. Now, the final velocity is going to be 14 meters per second, right? And the initial velocity we're assuming is 0, and there's the thing. So we know the change in kinetic energy. We know the change in kinetic energy is going to be 1/2 mv squared, mv final squared minus 1/2 mv naught squared, right? Okay, and the power is going to equal our change in kinetic energy over the time. So we've got the power. So if we find this change in kinetic energy and divide by divide by the time, we get the power. But we know the power, we know the kinetic energy. So to get the time, we just flip-flop that around and we get the change. So the change in kinetic energy over the power gives us how long it took. Now I think, so let's take a quick so let's take a quick look at part B. What does part B say? How long in seconds will this acceleration take if the car also climbs a 3.25 meter high hill in the process? Oh, all we're doing is we're adding the, well, okay, right away you see what your answer is. Dull. Sorry about that. And then, so we know it's going to take longer because why? He's got to go up the hill. So let's go back and look at this. So we're going to keep the same power because the power stays the same for this. The power output of this car stays the same. So now for part B, it's just going to be the power is equal to the change in kinetic energy plus that change in gravitational potential energy, mgh, over that new time. So again, that's how you go about doing that problem. Here's part A, and here's part B. It's a little tricky, but it's one of those. It's like, really, that's it? Yeah, that's it. All right.